Hello everyone, welcome to day 25 of Leetcode May Challenge. Today we have question number 354, Russian doll envelope. In this question they have given us 2D array of integer envelope where envelope of I is equals to w comma h represent the width and the height of an envelope. One envelope can fit into another if and only if both the width and the height of one envelope are greater than the other envelope width and height. And we have to return the maximum number of envelope we can put one inside the other. In example 1, these are the envelopes given to us where the first 5 represent the width of the envelope and 4 represent the height of the envelope. And the output is 3, that is they are putting these 3 envelopes we can put inside each other. We can see this, the width of the first envelope is smaller than the width of the second envelope and the height of this first envelope is smaller than the height of the second envelope. So 5 comma 4, so 2 comma 3 can come inside 5 comma 4, like we can put 2 comma 3 inside 5 comma 4. And similarly now the width of the second envelope is 5 and the width of the third envelope is 6, so the third envelope width is greater and similarly the third envelope height is also greater. So now both of these envelope we can put inside 6 comma 7, that is this third envelope. So that is how the maximum size we can get is 3. In example 2, they have given us some envelope but all of them have the same width and height, so only one envelope we can put. We cannot put these all envelope inside each other because all have same width and height, that's why we are returning 1. So let's understand this question more betterly. This question is more like we have to put box in a box in a box and we have to find the maximum number of boxes we can put inside each other. So in this question is somewhat related to longest increasing sequence. If we can find the longest increasing sequence, then after this we can put how many boxes we can put inside this box and then we can return the maximum box. So this question is more like this. So first let's understand largest increasing sequence by this example, like how largest increasing sequence work. So suppose this is the array given to us. Just let me convert this to pen. Yeah, this is the array given to us and we have to find what is the maximum increasing sequence we can make using from this array. So from this array maximum increasing sequence we can make of 10, 12, 17 and 22 that have the length 4. But how are we going to achieve it? So the first thing is we will create a DP and we will find using this particular number what is the largest increasing sequence we can find till this index. So using this particular this is the 0th index and using only 9, the longest increasing subsequence we can perform will have the only one length, that is 9. So we can perform only one longest increasing subsequence using this number. Coming to index 1, this is 2 and we have to find the longest increasing subsequence which we can perform using this number or the number before it. So as 2 is, that means our longest increasing subsequence should end at 2. So 9 is greater than 2, 9 cannot be end at 2, so the longest increasing sequence we can form using the 2 is 2 itself, a number starting with 2 itself. Now coming on the index 2, the largest increasing sequence which we can form using 9, 2 and it should end on 10. So we have two options. Either we can go with 2 or 10, either we can go with 9 or 10, and both ways our length will be 2. So here we have to restore the length. So the longest increasing sequence length ending on 2 is 2, ending on 10 is 2. Now coming on the index 3, we have to see the longest increasing sequence should end on 12 and should take all these maximum of all these numbers. Like on 12 it has the option to go with 9, we can form 9 and 12 because 12 is greater than 9. We can form 2 and 12 because 12 is greater than 2. We can form this, it already have the length 2, that is 9, 10 and 12, or if we can consider if this would have gone with 2, then we can form 2, 10 and 12. So the longest increasing sequence possible if that particular sequence is ending on the index 3 or the number 12 is of length 3. So this is of length 3. This is the answer we are storing. Like till here, the longest increasing sequence we got, and that is of length 3. Similarly, coming to 1. Now 1 we cannot put anywhere, because every number on its left hand side is greater than 1. So 1 can perform the longest increasing sequence only with itself, because to form the longest increasing sequence, this number should be greater than the left part, but it is not. So the longest increasing sequence which is ending on 1 is 1 itself, so its length is 1. For this was for index 4. For index 5 we have the number 17, and for the number 17 it can form the longest subsequence with 9, that could be 9 and 17, or it can go with 2, it is of length 2, and the other it can form with 2 or 17, that total length of longest increasing subsequence ending at 17 length is 2, or it can go with 10. Again it will have the possibility, either it can go to 9, 10, 17, or it can go to 2, 10, 17. 2, 10, 17. And the other possibility that 17 has is, let me raise this so that I can write the other possibility. One was 9 and 17. Let me write this 3 sequence one, that is 9, 10, 12, 9, 10 and 17, and the other it can have is going to the 12. Like take any one of these. Let's go with 9, 10, 12 and 17. 9, 10, 12 and 17. So the longest increasing subsequence ending at 17 is of length 4. So that is what we are going to store here. So here we have stored the length 4. And similarly we are going to 22. We can store the longest increasing sequence ending on 22 is, either we can put 22 at the end of it, so it will become the length 5, or we can put at the end of it, I am not writing this whole over here, so just to explain you, so it will become the length 4, or I can add 22 over here. This can give me length 3. So out of 3, 4 and 5, 3, 4 and 5, the longest increasing subsequence which I can form is of length is of length 5. Yeah, I have given here 4. This is wrong. This is 5, because the longest increasing subsequence we can form from this array is 9, 10, 12, 17 and 22. Similarly, this concept we have to use inside the Russian doll envelope, because if we suppose this has this width and height, if this width and height is less than this width and height, then of course this 9 can come inside, this 9 box can come inside the box which has the value 10, and this 10 can come inside the box, I am making the circle but consider it as box, which can come inside the value 12. Similarly we can have some similar other box. 17 can come in, like these all can come inside 17, so the maximum, and this is like 22, so the maximum possible length is 5. That what we have to return. So that's why LIS concept is very important for the Russian doll envelope, and now we can form the Russian doll envelope problem very easily. Now the thing is, they have given us, this is the width and this is the height. So after sorting this on the basis of the width, we got this sorted envelope array. So here we have the sorted envelope array, and now we will similarly use this LIS concept and over here, and we will find the maximum number of envelope we can fit inside one another. So this is 1, 2. So this can fit inside one another, so this length is by default 1. Now 2, 3. First we will check, is its width greater than the left hand side width? Yes. Like we have to find the maximum number of envelope that has this largest value 2 and 3 till here. We have to find first till here. So this width of the envelope present at the index 1 is, it should be greater than the width of the envelope present at index 0 and the mandatory condition is height of the envelope present at the index 1 should also be greater than height of the index present at the envelope 2. If this condition is true, that means we can fit, this is 1 comma 2 box, we can fit 2 comma 3 inside it. So now the length became 2. So that's why we are writing it over here. And which box we fit? It is 1 comma 2 and then 2 comma 3. Now we are moving to the next index. We have 5 comma 4. So now we will check to both of these. Is 5 less than 2? Yes. Is 4 less than 3? Yes. So one way is, it has the length 2 and plus is 1 length. We can basically, what we can do is, we can take the maximum of these both length, that is 2, and then we can do plus 1. But the case is, it should be less, like the width of the width, because here we have checked, so they are already sorted. So over here, width of the second width, like envelope width present at the index 2 should be greater than envelope width present in the index 1, which is true. 5 is greater than 2. Similarly for a height, 4 is greater than 3, so its length will become 3. And which all the envelope will come inside each other? 1 comma 2, 2 comma 3 and 5 comma 4. Now we have the other index. Now we are on the index 3. So what we will see is 6 less than 4, is 6 less than 5? Yeah, 6 is less than 5. So this is true. Width of this is less than 3, width of this. But is this less than 4? Yeah. No, these are equal. Equals are not allowed. So 6 comma 4 cannot come with 5 comma 4. So now we will see to 2 comma 3. Is 6 is less than 6 is greater than 2? Yes. 6 is greater than 2. 4 is greater than 3? Yes. 4 is greater than 3. So one pair it can make the pair with 1 comma 2, because it can come down to this. It has 1 comma 2, it has 2 comma 3, and it has then again 6 comma 4. So the maximum Russian doll length we can form, which can come inside each other using 6 comma 4 is 3. We can go with 1 comma 2 also, but it will not make any sense. Like if we put 6 comma 4 back of 1 comma 2, but it is of length, it will only form it will only give the maximum length, that is 2. So and this is giving 3, so the maximum we will take, so 3. So 3, like till 3, using 3 envelope we can make a Russian doll, one inside another, one inside another. Basically this is like, this is 1 comma 2, this is one box, and then we have the other box which have 2 comma 3, and then we have a bigger box which have 6 comma 4. In Russian doll also, a smaller doll will be inside a bigger doll, and then bigger doll is inside another bigger doll. So this is what is happening over here also. Now we are moving to the next index, and now we see, is 6 greater than this? No, these are equal. So this we are not going to use. We are going to see all the above. We are going to loop all the left side element. Now, then we are going to, of course we are going to loop from the 0th index, but here I am showing you this way. So first it's going to loop with the 1 comma 2. So it will get the Russian envelope of 2 length, 1 comma 2 and 6 comma 7. So using this, it got the Russian envelope of 2 length. Then it will come to this. Using this, yeah, 6 is greater than 2 and 7 is also greater than 3. So using this, it can form the Russian doll of length 3. 1 is 2 is of both this, and then 6 comma 7 will come here. So it can form of length 3. Now we are coming to 5 comma 4. Using 5 comma 4, 6 is greater than 5, correct. 7 is greater than 4, correct. So now it can form the Russian doll of maximum length. 3 is of this, and this is also going to join them now. So it will become 4. Now we are coming to this. Is 6 and 6? No, they are equal. So equal cases are not allowed. It has to be perfectly greater than both width and height. So out of this 2, 3, 4, what is the maximum? 4 is the maximum that we are going to store here, and that is the maximum Russian doll we can form using 6 comma 4. That has the biggest element, that has the biggest box, 6 comma 7. Now we are coming on the next index, 8 comma 8. Now again we will check from the starting. Is 8 greater than 1? Yes. Is 8 greater than 2? Yes. Width and height of this index is greater than this. So the maximum length of the Russian wall it can form is 1, 1 of itself and 1 we are adding this, so 2. Similarly for this, 2 of itself, 1 we are adding this, because they are greater, it's clearly visible, so this is of 3. And then we can go to 5 comma 4, clearly visible, they are greater, so this can form the Russian doll of length 4. 3 like these 3 itself, and 8 comma 8 will join them. And the other we have 6 comma 4, they are perfectly greater, 3 of this and plus 1 of 8 comma 8. And then we have 6 comma 7, it is also greater, so it can have the length 5. So out of this, what is the maximum length is 5. So we will add over there, like using this as the greatest, like if we find this Russian doll has the greatest width and height, so the maximum doll can come inside is like of this index, that is 4, and it itself is 5, so that is the maximum we can get. Now we can come to 9 comma 7. Now we will again check. For this we will go to loop, going to loop from the left, I mean this I'm making the wrong direction. We have to find of 9 comma 7, so we are going to loop from 0 to this index. If this index is, this is index 6, so we are going to loop till 5th index, 0 to 5th, and then we will check for the maximum Russian envelope we can form. 9 comma 7, this has the one length, this is clearly greater, so this can form of length 2. Then we have 2 comma 3, clearly greater, 2 plus 1, like using 1 comma 2, 2 comma 3, and then we will get this 9 comma 7. So it will form the Russian doll envelope of maximum length 3. 5 comma 4, 3 itself and 1 this, make the length 4. Then we have 6 comma 4, 3 itself and 1 this, it will also make the length 4. Then we have 6 comma 7, 4 this and 1 this, length 5, because it's clearly greater. So okay, this will not happen, this is a good case, I was just making a mistake. Over here the length is 7, and over here also, sorry, over here the height is 7, over here also the height is 7, though the width of the this index is greater, but width of the this is smaller, so this is cool, but they have the same height, so this we are not going to consider. And then we will move to this index. Its width is smaller than this index, yes, but this is greater, height is greater, so this is also not acceptable. So these both is not acceptable for 9 comma 7. So we have to choose the maximum it can form from this, that is 4. So if we have to return the maximum Russian doll, we can return this 5 on 8 comma 8, like, okay, I'll just draw this. This is like 1 comma, if we are putting 1 comma 2 inside the envelope Russian doll 2 comma 3, because it has the greater size. Then if we are taking 5 comma 4, then we are taking 6 comma 7, and then we are taking 8 comma 8. So these are the Russian doll we can which can fit inside each other, and which has the length 5, and that we are going to return as an output. So now the thing is, I think why the LIS concept is used here, we can get it while I was traversing through this array. I think I made this point very clear. Now let's code it up. So first we will create a maximum, we will initialize it with 1, because if we are having this envelope and if we are having this envelope itself can make one Russian doll, so at least 1 is the max, so that's why we are initializing it with 1. And now what we have to do, we have to sort the envelope based on what? We have to sort them based on the length, sorry, based on their width. It's not length, it's width over here. So we have to sort them based on their width. So this is the small function, and then we will take out the length of the envelope, and we will create a DP that will store our answer, and we will fill this DP by 1, because each and every particular envelope present inside it can form a Russian doll one with itself. So that's why we are filling it with 1, and then we are looping it. For LIS, this is for, we have to this loop is same for LIS. Like for here we were this particular, as we can see over here, this particular index can form the longest increasing sequence with itself. This 2 can also form the longest increasing sequence with itself. This 10 can also form the longest sequence with itself. So everyone can have the length 1. That's why we have initialized everything with 1. And the other thing is, LIS is why we are using this, because we are checking if this is smaller than this. So means these are forming the increasing sequence. So that's where the LIS logic is coming. So we will write the same LIS logic. So that is, it will go till the length end of the envelope, but the second loop will only go to the left side, till the left side. I mean wherever the index is, -1 position left to it, it will go over there, and then we will compare. What we will compare? Envelopes width should be, we are on the envelope, its width should be, okay, let me just copy this envelope width should be less than the left side envelope. If this is strictly less, similarly there should be one more condition. If its height should also be strictly less, its height should be envelope of J, comma, yeah. So this is like, we are on currently on this envelope, and we on which envelope we are on the left side of it, its height should be strictly less, and we are on the envelope and its width should be, and the on the left side its width should be strictly less. If this is the condition holding true, then we are going to increase its length. That is math dot max of I and dp of j plus 1, maximum of, in itself if it is having the length, let me take this example, like over here with itself 2,3 is forming the maximum Russian doll inside this one, like of length 1 with itself. But now at the left of it, it have width also less and height also less. Now it can form the Russian doll of length 2, that is 1,3 and 2,3. So out of 1,1 and 2, which is the maximum length? 2. So that's why we are returning, and that what this loop is doing. This is done, and then we have to return the maximum. So maximum of the maximum which it contain, or the dp of I. We will store the maximum, and then we will simply return the maximum. This is done. Let's run this code. It's working. Let's